just a soda can that I emptied. And I did rinse it out, so there would not be any leftover soda in there, I hope. What I'm gonna do is just put a little dab of water, not a whole lot, in the bottom of the can, okay? You with me?
Yes, ma'am.
Okay, I'm gonna put this can on the hot plate, and I do have it on high, and we're just gonna let it sit there for a minute. This is aluminum. This can is made of aluminum. So what is it? It's a metal, which makes it a good what?
Conductor.
A good conductor. So does that mean that the heat's gonna transfer easily or not? Easily, you're right. So aluminum does allow heat to transfer very easily through. Okay, it's starting to steam. I'm letting. Can you see the steam coming out?
No.
So,
I'm gonna let it do that just a second. Are you ready? Okay, here we go.
Why you just cursing?
I did. You think I did that? There's no way that did that.
burn it through the table.
He jumped back. He jumped back. She hit that.
Now,
He said,
Oh,
all right, quit. Jot down some ideas about what you think. How did this happen? What caused this can to crush like this? And I promise you, let me get a can.
hey, you do it again.
Let me do the same one so I'm not pulling your leg. Okay, if I take a regular can and I try to crush it with this thing, that's all I can do. That's as close as the handles will come together. So that's what I do when I crush it with these. Now you compare the two.
whoa. Can we feel it?
I
I see
No.
I see Superwoman.
That's how you get your
All right, now think about what we've done so far this year. Think about everything we've studied and what you know just from what we've done this school year. What else? What other ideas might you have?
Probably wrong, but I was thinking like since you have like
Look what I did
water
today.
and stuff inside
That's
the
my
can, it
thinking.
makes water cool really fast. So you should mix it up
Wait.
with the cold one.
Listen.
Cause pure pressure and crush.
Caused what pressure?
Okay, I'm gonna press me.
Just like peer pressure?
Yeah.
Okay, so Terry has said that because we had the hot water on the inside of the can, and she's taken this, I know you know this, that when we heated up the water, what happened to the molecules? They started moving faster and they spread further apart. She says that because I put it in here with the cold, that the two, the pressure, the peer pressure, because the hot, like the hot against the cold, is that what you're saying?
Yeah, like since it just came all together at once, it pulled up really fast and it caused it.
Okay, cooled off really fast, caused it to crush. What do you think then caused it to crush? The hot water, the cold water?
Like pushing together, trying to cool off and heat up at the same time.
Are pushing together? Okay, let's go with that. Let's talk about what else is here? What else have we studied so far this year? We have studied energy, and that would be what you just told me about, the heat energy and the molecules moving faster, spreading further apart. You told me the two mixed, so the heat cooled down really fast, so you think the heat transferred then to the cold water? Okay, what else have we studied?
Conductors and insulators.
Density? Does that have anything to do with density? The hot water and the cold water? Yeah, it does. It sure does. But now, tell me this. What are we studying right now?
Well,
The atmosphere. What's in the atmosphere? Air is in the atmosphere. Do you think there's anything to do with air?
Yes.
Does air put pressure on things?
Yes.
I know what glass.
You know,
Wanted down, air went in.
you think air went in, but now the the opening was under the water. So could air go in if that were the case? No. Excuse me. No, it couldn't. So where could air be? If air couldn't go inside, where could it go? On the outside. Do you think air could do that?
Yes.
Yes, you're exactly right. Let me show you. What's going on is the water is heating up. The molecules are moving faster. They're spreading out. As the water changes to a gas, what's it pushing out of the can? What's in this can right now? Air. This can is full of air. There's no soda in it. It's full of air. Okay? So as the water heats up, the water vapor is rising. What's it pushing out of the can? Air. So what is this can full of right now?
Air.
Water as what?
As a gas.
As a gas. Water as a gas. Good. Now, what happens is when I take this can, I seal it off because I put the opening of the can under the water. Okay? That means no air can get in. Aluminum is a good conductor. We've already said that, right? Okay? As I put it in this cool water, and it is cool, it's not cold, but it's pretty cool, then the aluminum allows the heat energy from the can to transfer very quickly. You saw how quickly to the water. What happens to the water molecules inside the can when they cool down?
Is it going slower?
They move slower. They condense, don't they? So they come back together. So now I've got all this space inside that can that's filled with nothing. And the air pressure on the outside then pushes in and collapses the can. You with me? All right, so now it's full of hot water vapor. And when I flip it over,
It's so tiny, it's mini version.
It don't burn your hand.
no, that's how fast the heat transfers.
I'm scared.